So this is a simplifying radicals section, and this will lead us right into the using the quadratic equation. So a radical is, you can think of it as a square root, cube root, fourth root, just the parts that you're going to need to know the term. So the terminology is this number right here is called the index, and that tells you the root. So when there's no number there, it's square, so that means 2. Otherwise, you could have a 3, a 4, a 5, it doesn't matter. It just tells you how many numbers are you using to get the value that's in the middle. And the value underneath the symbol is called a radicand. So whatever number is under here, you are multiplying the same number however many times the index tells you to. So in other words, it's the inverse of a exponent, excuse me. So if you have x squared, what undoes it is the square root. So when you do the square root of something squared, those things undo each other. So those are your inverse operations, like adding and subtracting are inverses, multiplying and dividing are inverses. Powers and square roots, or roots, are inverses. So when those undo each other, you just get x out. So if I had the cube root of 5 to the third power cube root, those undo each other, so I end up with just 5. So that's just kind of the basics of a root. It's what number do you multiply together, the index number of times, in order to get the radicand. So when we're working with radicals and simplifying radicals, what you want to keep in mind is what are the perfect roots, okay, or the perfect values. So what I mean by that is we're going to deal with just square root, because that's what we're going to deal with in the quadratic. So if I said 1 squared is 1, 1 is a perfect square. 2 squared is 4. 4 is a perfect square. You can kind of think of it as when you have a square. If I said 2 times 2, if each of the sides were a length of 2 feet or 2 inches, the perfect square is 4 because it's 2 times 2. If I did 3 squared is 9. 9 is a perfect square. 4 squared is 16. 16 is a perfect square. So what you want to have in mind is all the perfect squares. So if I keep going, let me erase this. If I keep going, my perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and we'll continue, 196, and 225. These are the first 15 perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared. So you have to have an understanding of those perfect squares, because when we're simplifying, we're looking for the perfect square. So keep those in mind, write them down. And we are going to simplify a radical. So if I had the square root of 12. Now, you could go to your calculator, punch in square root of 12. It will give you an exact number, and I can tell you what that number is. So the square root of 12 is about 3.464101615. You can see it's not an exact answer, but I know that there's a perfect square below it, so square root of 9. There's also a perfect square above it. So the square root of 9 is 3. The square root of 16 is 4. So the square root of 12 is somewhere in between 3 and 4. Now this little technique is really nice to know, so that way you know that your answer makes sense. Okay, so you take your number, you pick a perfect square below it, a perfect square above it, and you know that your value is somewhere in between those two perfect squares. Let's try another one. How about the square root of 32? Okay, so the perfect square below it is 25. The perfect square above it is 36. That means that 32, the square root of 32, is somewhere in between 5 and 6. Now, you can go to your calculator, plug it in, and this is about 5.656854249. Okay, again, somewhere in between. All right, now, we're not going to need to use these exact values. And you can tell it's really not exact because it keeps right on going. So when we're simplifying a square root, what we're going to do is we're going to break these numbers up. So I'm going to take 12. So remember when we did prime factorization? So I'm going to take 12 and I'm just going to break it up. One of my numbers has to be a perfect square. So I could use 6 and 2. 6 times 2 is 12, but neither 6 nor 2 is a perfect square. So you always want to make sure one of your values is a perfect square. So I'm going to use 4 times 3. So 4 times 3 is 12. My 4 is a perfect square. So I'm still going to take the square root. What's the square root of 4? Is the whole number 2. That's important. Square root of 3 is going to stay underneath the radical. Okay, now remember, all of these, you have two answers. You have a positive version and a negative version. Here's the reason. If I took the square root of 25, my answer could be 5, right? 5 times 5 is 25. I've used the 5 twice. I'm good to go. But I could also use negative 5. Negative 5 times negative 5 is also 25. So whenever you take a square root, you get two answers, a positive version and a negative version. And that's what this symbol means. I have two answers. I have the positive 2 square root of 3, and I have a negative 2 square root of 3. So always two answers. Okay, so let's try another one. So I am on page 61 of your packet. So if we did the square root of 72. Okay, now I'm going to do this in a little bit different way to show you that you can take multiple steps. You do not have to do this. The goal is to get the highest perfect square, okay? The highest perfect square that will go into both of those. Well, this one, I'm going to do it two ways so you can see the progression. This one, I can use 36 times 2. 36, let me double check. Yep, 36 times 2 is 72, so I'm good there. So now I'm still taking the square root. Square root of 36 is a whole number 6. The 2 is not the perfect square, so that stays underneath the radical. And again, it's positive or negative. Now, there's another way to do this. So let's say that you're walking through this problem and you don't see that 36 is your highest perfect square, but you do see 9 times 8. Okay, so you can break this down. I'm still following the rules. One of my numbers is a perfect square, so I'm still okay. Square root of 9 is 3. Square root of 8 stays underneath my radical. Okay, but when you look at 8, you go, oh, there's another perfect square in there. So you're going to break this down again. Okay, so 8 is 4 and 2. 4 is a perfect square. I'm going to take the square root of both of those. So the square root of 4 is 2. This square root of 2 stays underneath, but I had this 3 still. Okay, so I still have to use that 3. So I'm multiplying. 3 times 2 is 6. Square root of 2, still plus or minus. You can see I still get the same answer. So if you don't see or don't use the highest perfect square, you can just keep breaking it down and then multiplying your whole numbers. The whole numbers that get pulled out, those perfect squares that get pulled out. All right, let's do a couple more. So simplifying a radical is all about knowing your perfect squares. So let's try number 3. So this is 10 plus or minus the square root of 16 all over 4. This is number 3 on page 61. Okay, so now what you're doing is you're using the setup of the quadratic equation. So remember, all of this is to get us to the quadratic equation. We're going to do two sections today. We're doing radicals and starting with the quadratic equation. It kind of all fits right together. Your homework is going to be one page. It's going to be, I believe it's 64 and 65 or 65 and 66. Okay, so here we go. Perfect square. So this one, there's not going to be a value left underneath the radical. Square root of 16 is 4. So it's 10 plus or minus 4 all over 4. So remember, this plus or minus, you have two answers. Two problems going on. You have 10 plus 4 divided by 4, and you have 10 minus 4 divided by 4. So anytime you see this plus or minus sign, just remember I have two things going on. I have the plus version and I have the minus version. So now we're just going to simplify. 10 plus 4 is 14 divided by 4. Divide both by 2, so I get 7 over 2. All I'm doing is reducing. And then over here, I have 10 minus 4 is 6 divided by 4. Divide both by 2, and I get 3 halves. So my two answers are 7 halves and 3 halves. So those two answers. So why do we have two answers? It's because we are working in quadratics. And remember, a quadratic is a parabola. So if I were to graph it, you can see it's going to cross at two places. That's what we're going to look for. We're looking for the two places that my parabola crosses. Okay, so let's try number 5. Actually, let's do number 4 so that you can see when there is a radical underneath, when there's a radical left in your answer. So I have 15 plus or minus the square root of 45 over 6. So this is number 4. Okay, so we're going to do the same thing. I'm going to take this 45 and I'm going to split it. One number has to be a perfect square. So I end up with 15 plus or minus. The square root of 9 is 3. Square root of 5 stays underneath the radical, all divided by 6. So when you look at this, remember, I cannot simplify a whole number with a radical. All I can do is simplify whole numbers with whole numbers. Okay? So what this looks like, if I were to split this up, it's 15 divided by 6 plus or minus 3 square root of 5 divided by 6. So this 6 goes to both pieces. So 15 over 6, reducing by 3, I get 5 over 2, plus or minus. 3 goes into both 3 and 6. So I have 1 and 2 down here. So I have square root of 5 divided by 2. So I can rewrite this as 5 plus or minus square root of 5 all divided by 2. You can write it this way. That's completely okay. But just know that these are the same thing. Okay? So with this one, we again split it up. One of our values has to be a perfect square. Square root of 9 is the whole number 3. The non-perfect square stays underneath my radical. And then all I can do is divide whole number by whole number. Okay? All right, next step. So now we're going to introduce a negative underneath a radical. So when you have a negative underneath a radical, what you have, so this is number 5. Okay, so now we have a negative underneath the radical. This is called a complex number. So now we are in a different numbering system. Up until this point, we have been in the real number system. Now we're working into the complex number system. So with the complex number system, this you end up with imaginary numbers. Okay, imaginary numbers. Now, where does this is a fairly new value. Where it was discovered is in the vortex, the amount of speed in the vortex of a tornado or a hurricane. So what they're doing is all of a sudden they were calculating the speed and there was a number underneath the radical. So they had to give it a name. They called it an imaginary number. This negative underneath a radical, they give it the value I. which stands for imaginary number. So usually you see it as a cursive I. It doesn't have to be. I just like cursive because it's a little bit easier to read than just that or just that. So just know that an I represents a negative underneath a radical. Okay? So I cannot do anything with this value until I pull that negative out. So what I'm going to do is anytime I see a negative underneath the radical, I'm going to pull this out. It's going to be I square root of 28. And again, plus or minus, always plus or minus. So now that the negative is gone, now I can simplify this. I'm going to break this up. 4 is a perfect square. 7 is not. I'm going to take the square root of both. Square root of 4 is 2. 7 stays underneath my radical, and my I is still part of the outside. So the I is no longer underneath the radical. Pulled my 4 out as a 2, multiplied it by my I. The 7 stays underneath the radical. Okay, let's try number 6. Square root of negative 72. Now, we already did positive 72. So negative 72, the only difference is I'm going to pull this negative out. I have I square root of 72. Break this down. 9 times, caught myself. Larger number, 36 times 2. Square root of 36 is 6. My I gets dropped down. Square root of 2. Plus or minus. So anytime you have a negative underneath the radical, you will have an I in your answer. What this does when we get to graphing is if you have an I in your answer, your parabola is going to be going away from your x-intercept. Because remember, this coordinate system is in the real number system. With an I, we're working outside the number system, so it doesn't actually cross the x-axis. So it can go up like that, it can go down like that. Basically, the idea is when you have an I, you know that your parabola will not cross that x-axis. And it's just a help when you're graphing. All right. So let me do one more in this section. And then I'll do a second problem. Okay, so this is number 10, our second video. So we have negative 8 square root of a negative 144 all over a negative 4. Okay, so you see a negative, you're going to pull this out as an I. Now you can work within the radical. So square root of 144, so this is where you need to know your perfect squares. Square root of 144 is 12. So I have negative 8 plus or minus 12i all over negative 4. And now I can simplify. This 12 is a whole number. Okay, the I is taking care of the negative. So the 12 is a whole number, so I can actually simplify. So negative 8 divided by negative 4 is 2, plus or minus. 12 divided by negative 4 is a negative 3. But remember, there's two versions here. There's negative 8 plus 12i over negative 4, which is 2 minus 3i. Don't forget my I. And then I have negative 8 minus 12i over negative 4, which is positive 2 plus 3i. So that's where the plus or minus comes in. So anytime you have plus or minus here and you have positive or negative here, you're still going to end up with plus or minus. So 2 minus 3i and 2 plus 3i is the same as 2 plus or minus 3i. I'm going to stop this video and then we'll restart with the quadratic equation.